A plus B squared. We can see this is A plus B times A plus B. We do distribution this way, we will get A squared plus AB plus BA plus B squared. We know AB and BA are like terms, so this becomes A squared plus twice AB plus B squared. So we remember this as a formula. A plus B squared is A squared plus twice AB plus B squared. We call this a perfect square trinomial because it can be looked as a perfect square of A plus B. We also mentioned if this is A subtract B, then you get almost the same thing except here is A squared subtract 2AB plus B squared. We use the formula square of A plus B equals A squared plus 2AB plus B squared to avoid the confusion with the coefficient of ABC for quadratic functions. I like to change the symbols. I'll make it like x plus k squared. We know this will look like x squared plus 2kx plus k squared. Now let's compare this with our standard form quadratic. If we write it as ax squared plus bx plus c, what do we see here? We see A is 1 and B is this 2k, and this C is k squared. If we have an x squared plus bx plus c, we're going to change this as x squared plus twice of b over 2, then times our x. I'm leaving the c out of the picture. To complete square, I have to match this one with the b over 2 square. So I'm taking b over 2 square away here. Then we get this part is our complete square. It's the square of x plus b over 2. And this part, we just clean it up. It becomes 4 at the bottom. Then the top is 4c subtract b squared. Some people write it this way, x plus b over 2 squared minus a 4, then the top is b squared minus 4c. However, this is how we do complete square. How can I use complete square to change this equation to be a vertex form? The way we do is x squared plus 6x. I leave 5 out of the picture. Now, I need a square number here, and I'm taking a square number away. And this square number is half of b squared. And our b is 6. So this is a half of 6 squared. That is 3 squared, which is 9. So I'm putting 9 here and take 9 away. Now this part is the complete square part. It is the square of x plus 3. And this part is subtract 4. This is our result of completing square. To change this equation from the standard form to the vertex form. How do we solve this equation? Using complete square scale. We can do it this way. First, I know I don't need this constant, so I am moving this constant away to one side. So I have x squared plus 6x on the left, and the right side is -5. Now I need to add a square number. Now I'm adding a square number. Now I need to add a square number to the left, and I need to add a square number to the right. What's this square number? Remember, we need to add the half of b squared. And our b is 6. So half of b squared is 6 over 2 squared. That is 3 squared. That is 9. So we're adding 9 here. We're adding 9 to the right side also. Now the left side becomes a complete square. So the left side is the perfect square of x plus 3. This 3 is half of 6. So now the right side is 4. Now we can solve our equation because it is a complete square. So we are going to take square roots on both sides. We're taking the square root on both sides. But when we take square root, we need to make sure it's positive and negative because both positive and negative squared will get the same value. So this square and the square root cancel each other. We get x plus 3 equal to positive or negative 2. So we are going to separate our equation. Our first equation is x plus 3 is 2. The second one is x plus 3 is negative 2. So this one, we subtract 3, subtract 3. We get our x equal to negative 1. That's one solution. Here, we subtract 3, subtract 3. We get x equal to negative 5. That's another solution. So our solution is negative 1 and negative 5. We just solved this quadratic equation using completing square scale. Thank you.